Hello everyone, I am Şevval Altay and I'm a fourth-year molecular biology and genetics student at Bilkent University. Today I will present my PHYS102 project. The name of the project is Examination of Faraday's Law of Magnetic Induction, and for this project I used 4 different coils with different radius and different turn numbers and analyzed the induced voltage when a strong magnet dropped through the coils.
Faraday's law of electromagnetic induction indicates that when magnetic flux through a coil changes, an induced EMF is created around the coil. Magnetic flux is equal to the product of loop's area and magnetic field. And Faraday's law states that induced EMF is directly proportional to the rate of change of magnetic flux, and each turn of a coil experiences the same change of magnetic flux. Overall, the formula for induced EMF can be written as this. Thus, Faraday's law suggests that when turn number and radius of a coil is increased, induced voltage will be increased too. To analyze this, an experiment with 4 different coils was performed. First coil has 5 cm radius and 20 turns. Second coil has 3 cm radius and 20 turns. Third coil has 3 cm radius and 15 turns. And lastly, the fourth coil has 3 cm radius and 30 turns.
Here you can see the experimental setup and the other equipments I used. A coil was placed to a fixed point on a ruler with tape and a voltmeter was connected to coils. A strong magnet was dropped through from a 5 cm height, and this process was repeated for each 4 coils.
Here is the first coil. Here is the second coil. Here is the third coil. And lastly, the fourth coil.
The induced voltages were measured with using the min-max recording feature of the voltmeter and noted.
In table 1, it can be seen that when radius of coils increase, induced voltage is increased too. And in table 3, it can be seen that when number of turns are increased, induced voltage is increased too. However, there were some experimental errors which can be seen in tables 2 and 4, which are likely caused by deviations in coil placement and dropping magnet, which can cause differences in magnet speed, and also problems in connections or environmental factors caused by non-perfect conditions. Graph 1 is plotted for induced voltage versus radius, and graph 2 is plotted for induced voltage and number of turns. Both graphs shows a linear increase in induced EMF when radius and turn number are increased.
To conclude, despite some errors and discrepancies, this experiment successfully proved that when turn number and radius of a coil is increased, induced voltage is increasing too, which shows a strong agreement with Faraday's law of magnetic induction.